Hi everyone and welcome back to Activity 36. Today we are going to talk about solving our matrix equations. So we've been representing our systems of equations into our matrix equation format of ax times b. And today we're going to actually talk about being able to actually solve so we know what that variable matrix x is standing for. So what we're going to need to do to undo this equation is essentially when you have your matrix, you can undo it by taking the inverse and getting the identity matrix. Now, what we do to the left-hand side, we must do to the right-hand side. So we're going to make sure that A inverse comes first, since on this side that became, we had A inverse times A, so A inverse times B would have to be done on the second side. And when we end up undoing this, we end up getting the variable matrix by itself so we can find that final solution. So anytime you want to figure out what your variable matrix equals, you want to make sure, again, you are taking A inverse times B. This is kind of the magical formula of the day. So we're going to start out each of these systems. We are going to represent them by a matrix equation, So we have this system, and we can represent it as 2 over 1, 3 over negative 1, x, y, and then equaling that constant matrix of 7, 1. So in order to get our final solution, we need A inverse times B to get what x is by itself. So we're going to start off, we want to find A inverse. So we're going to take the determinant of matrix A. So 2 times negative 1 is negative 2. 3 times 1, which we're going to subtract away, is 3. So A times D minus B times C, we get our determinant value to be negative 5. And then to find our inverse, we are going to take 1 over the determinant value, so 1 over negative 5. And then we're going to flip around that original matrix. A and D switch spots. B and C switch signs. We now have negative 3 and negative 1. And if we distribute that value through, we have negative 1/5 times negative 1, which is positive 1/5. Negative 1/5 times negative 3. The negatives cancel and we just get 3/5. And then we have negative 1/5 times negative 1. Again, that's positive. Negative 1/5 times positive 2 becomes negative 2/5. So this is A inverse, which we can now multiply by matrix B, and that's going to give us our final answer for what x and y are going to represent. So we can type this into our calculator. We have a 2 by 2, and again, we have 1/5, 3/5, 1/5, and negative 2/5. And we can multiply that by matrix B, which is a 2 by 1 of 7 and 1. So we quit out of there. We have matrix A times matrix B. And we get 2 and 1 as our values for x and y. So sometimes you will see it just represented like that. Sometimes you'll see it represented in a coordinate to show the x and the y. So same thing then for number 2. We can set up our matrix equation 3, negative 2, 9, and 9. X and y are our two variables, and this time they're equaling our constant matrix of 8 and 54. So again, if we want to find eventually the value of the variable matrix, we're going to take A inverse times B. So we have to start off, we need the determinant of matrix A to help us find its inverse. So the determinant, we would do 3 times 3, 3 times 9, which is 27, minus negative 2 times 9, which is negative 18. 27 minus negative 18 ends up being 27 plus 18, which is 45. So now to find A inverse, we take 1 over that determinant value. And then we're going to take that original matrix, A and D switch spots, B and C switch signs. And when we distribute this through, 1 over 45 times 9, 9 over 45 is 1/5. 1 over 45 times 2 is 2 over 45. Oops. 1 over 45 times negative 9. Negative 9 over 45 reduces to be negative 1/5. And then 3 over 45, when we distribute that through, simplifies to be 1 over 15. So this is A inverse that we can then multiply by matrix B, and we get a product this time. Again, you could just type this in your calculator. So we have to edit. Again, you can just type these in, 1/5. Oops, sorry, we need a 2 by 2 matrix. We have 1/5. We have 2 over 45. We have negative 1/5 and 1 over 15. Multiply that by matrix B, which this time our 2 by 1 is 8 over 54. And when we multiply A times B this time, we get 4 and 2 as the value of our x and y. So you might see it represented like that, or 4 comma 2 for x comma y. All right, there is one on the back for you to try on your own. All right, now yesterday we talked about some of these real life examples where if we have food A, which has 10 grams of protein and 5 grams of fat, and food B with 6 grams of protein, 8 grams of fat, and we want our meal to have a total of 70 grams of protein and 50 grams of fat, we chatted yesterday that we can take the protein, food A, times food B's protein, that totaled 70 grams, and then we had food A's fat, food B's fat, and we want only 50 grams total. So we have this matrix equation that we set up, 10, 6, 5, 8, matrix A, A over B for that variable matrix. Okay, we talked about all of this yesterday. Now from here, we want to actually be able to solve this. So again, the magical way we're going to solve this is by taking, A times, A inverse times our constant matrix to get that output. Now, something you can do always is check your calculators if you want to just type these in as well. If you don't need to find the inverse by hand, you could always just type in this original matrix. So we had 10, 6, 5, and 8 for our coefficient matrix, 8. Oops. We want 8, not 88. And then this time matrix B, we can type in, this time it's equaling 70 and 50. It's not 700, 70 and 50. And this time if you take, oh gosh. D times 50. If we take A inverse times B, our calculator will do this for us, right? We didn't even have to find by hand if we don't want to. We can use our calculator to check that final answer. So we have A inverse times B. We see that our solution is 5.2 comma 3, which means we want 5.2 servings of food A, and we want 3 servings of food B. Another example we had yesterday was talking about ticket sales, and we said that the number of adult and children's tickets sold total was 300. It was $10 per adult ticket, $6 per children's ticket. Their total amount of tickets sold was 2,200. So we had 1, 1, 10, and 6. We had A and C as our variable matrix, and that equaled our constant matrix like so. So again, we can find what the variable matrix equals this time if we take A inverse times B. So I'm going to type in my coefficient matrix to start, my 2 by 2, my A matrix, And this time I had 1, 1, 10, and 6. My constant matrix this time, my B matrix, was 300 and 2200. And oops, this time, again, I'm going to take A inverse times my matrix B. And again, my calculator did the work for me. It calculated even that inverse if I didn't have to show my work there. So I know that I sold, if this is A and this is C, 100 adult tickets and 200 children's tickets. All right, this last one is talking to you about creating a blend of coffee beans, similar to the ticket problem. You want to set up your system of equations, your eventually matrix, and then solve. You can use, again, to solve for variable x, A inverse times B. Thanks everyone for watching. We will do more with these in class.